For Lab 1, I attempted to measure an object that had constant velocity. I did this by measuring a soccer ball that had been kicked. Based on Newton's second law, if there is no net force acting on the ball, then there should be constant velocity. This is true because after the ball had been kicked, there's no force acting on it that changes its motion. For the model and tracker, I chose to start the video at frame 17 to ensure that the ball had reached a constant velocity. The ball is moving to the left along the x-axis, which I called the negative direction. After the initial force, the movement of the ball shown in the video has a net force of 0. This means that the force being applied to the ball is equal to the force of friction, or the force that's opposing the ball. Next, I made a computer model in VPython that will model the motion of the object. I set the initial position equal to 0 and calculated the initial velocity as being negative 2.436 meters per second. This comes from the first 2 points in tracker from the data collected in tracker. So the total time of the video was 1.4 seconds, and with a net force of 0, as I said before. I predicted the motion of the object based on the equation for Newton's second law, which says that the final velocity is equal to the initial velocity plus the net force divided by the mass of the ball times the change in time. For this equation, the net force is going to be 0, so that makes the entire second part on the right side of the equation equal to 0, which also means that the function is dependent solely on the initial velocity of the ball. This velocity is then added to, or multiplied by the change in time, and then added to the initial position of the ball. This gives the new position for each iteration of time, which I made 0.1 seconds. After running the module, it will come up with graphs that show the position versus the time, and then the actual motion of the graph, which goes in the negative direction. I then used the data collected from the computational model and my experimental data to create a graph in Google Spreadsheets. There is some discrepancy between the experimental position and the model position. This error likely comes from some friction from the floor and the ball, and a slight force opposing it based on the offset spin of the ball, because the ball wasn't kicked directly straight. So in conclusion, an object that has a net force of 0 acting on it will remain at a constant velocity. In an ideal situation, Newton's second law can be used to predict the motion of an object solely by using the initial velocity and the time.